positive, go back to positive. It must go back to negative. So this is how it flows. Alright, so that's the first one. The positive go through this one, down, up, and then go back to negative terminal. Okay, our next one is our blue color. So now we know already, the red color, the positive one is allowed to pass through. The positive one allowed to pass through. So we have this and this. So the next one is the blue color. So the blue one is when we assume this one is positive, the other one is negative. So currents come from the positive terminal and then come here, pass through D3, blocked by this one. So it blocked by D2 again, so no choice but to flow down, you see, in the same direction, and then come back here, go up, okay, and then it's going to go back to the negative terminal, so it'll pass through D1 and go back to our negative terminal. The blue one is like that. Okay, that is how the current flow at this moment. So that means the blue one, if you look at the direction, no matter how your AC change polarity, the current always flow in the same direction through the RL. That means this is DC, even though this is AC, so DC. So both are allowed to pass through. Okay, both are allowed to pass through. So now you see that you don't lose half of the wave. So this one is called full wave because all the wave is allowed to pass through. So that is what happened in this type of full wave rectifier. So I call this one VP, negative VP. So I assume this one theoretically VP. And then this one is if there is no capacitor. See or not? The ripple voltage is very high. So I call this one the ripple voltage, VRIP, ripple voltage. And then when we have capacitor, the story will be different. We have this maximum, go to maximum, and then we know that capacitor will discharge here. So we are supposed to have this red one coming down to minimum, right? But it don't happen because of capacitor. And then the negative side will come. Okay, the negative side will come and also go down. So we draw all the waveforms in dotted line, so that we know where the graph will go later on. Now what happens next is the capacitor will discharge, and then until your blue voltage is higher, and then it go up, and then it started to discharge again. Okay, discharge again until the red voltage reaches a maximum, and then the whole process repeat over and over again. Okay, so now what happens next is, if you look at our ripple voltage, the green color one, the ripple voltage is very, very small. Okay, the ripple voltage is small, so that means it make it more efficient. Alright, so that is how with capacitor, with no capacitor. Regulated means with capacitor, unregulated or not regulated is no capacitor. Alright, so this one is more efficient in a way that it operates with 4 diodes arranged in something like this. So we call this type of arrangement bridge diode. D1, D2, D3, D4, they are called bridge diodes. Okay, bridge diode. Okay, so I have bridge diode, but I'm very lazy to take it out later some other time. Okay, so that is our full wave rectifier. So that is our application for full wave rectifier. Well, that's it for our rectification process. This is our video for tonight. Okay, so see you some other time.